Hello everyone. Today we'll be discussing about graph theory. So we'll introduce what is graph theory, how can we apply the concept of graph theory, basic concept of graph theory in electric circuit analysis, what are the importance of graph theory, why shall we study graph theory. All this we'll be discussing in today's lecture. So before starting our main course, let me tell you why graph theory is important or what is graph theory actually. Graph theory is a graphical way of representing an electric network. Thus, analysis of electric network using graph theory based approach would be a bit easy, especially for complex networks. For very complex networks, determination of current through a particular branch or voltage across a branch or getting sets of equation that describes that particular network is a bit difficult for very complex networks such as integrated circuits. Now, graph theory will enable us to get better solution for a particular complex electrical network in a simple way. So graph theory is mostly applicable for those complex circuits for which sets of equation cannot be obtained easily, such as if you want to get Kirchhoff's voltage law equation or Kirchhoff's current law equation for an electric network, it is very easy to get these equations. But s- as soon as the circuit becomes very complex, then application of KVL would be a bit difficult. In that case, what shall we do? We can go through graph theory based approach to get the uh, those sets of equation for that particular network. So graph theory generally involves analyzing circuit for especially for very complex circuits. Now, today we'll be discussing about the basic introduction of graph theory and basic terminologies associated. So what is graph theory? Graph theory is a graphical way of representation of any electric network in a simple way. So as I said, for very much complex circuits, it is much difficult to analyze that complex circuit by using network theorem analysis tools or by using voltage divider, current divider rules, Kirchhoff's laws. So to analyze very complex circuits, it is much easier to use graph theory concept to perform the analysis in a simpler way. For very large integrated circuits, this graph theory based approach is much easier to find sets of equation which describe the network. So as we all know, any electric network should be represented by sets of equation. So those sets of mathematical equation actually describes that network. So to analyze an electric network, sets of equation we should have. So for very complex circuit such as large electronic circuits or integrated circuits, it is much easier to use graph theory based approach to get those sets of equation. So that is why graph theory is important for electric circuit analysis. In next few classes, we'll be discussing about different matrix methods for graphical analysis of an electric network to get sets of equation of an electric network which may replace KCL or KVL. Now, today we'll be discussing in next part about the basic terminologies which are associated with graph theory. So those basic terminologies will be very frequently used in analyzing electric networks. So let us first get familiar with those basic terminologies. So let us start with what is a graph? See, here you can see this is a graph. The graph is a graphical representation of an electric network. So any electric network can be converted to graph. Now the question comes, How can we replace this resistance while converting it to graphical form? How can we replace the voltage source, or how can we replace the current source? All this we'll be discussing in this slide. See, you just need to remember that all the sources, voltage sources or current sources, can be represented in a graph by a short circuit and an open circuit respectively. That means if you have a voltage source, see, this voltage source is connected in between node 1 and node 4. Now, in between node 1 and node 4, there is a voltage source connected in the circuit. But here, in between node 1 and node 4, that voltage source is replaced by a branch, which is having a short circuit. So voltage source in a graph should be represented by a short circuit. But in between node 3 and node 4, there is one resistor and one current source. See, R, L, C, all these passive elements in graph should be represented by short circuit as like voltage source. So in between 3 and 4, there is a resistance which could be represented by a short circuit. But what about this current source? This current source is not mentioned anywhere in this graph. That implies current source should be replaced by an open circuit in a graph. So the conclusion of this part is voltage source, resistance, inductance, capacitance, all will be replaced by a short circuit while representing in a graph, whereas current source only will be represented by an open circuit. So here it is mentioned that graph is a network graph is a network in which all nodes and loops are retained. That means see here, one loop, node 1, node 2, node 3, node 4, all these are retained. But its branches are represented by lines. Branches means resistance branch, voltage branch, source branch, all are represented by lines. The voltage sources are replaced by short circuit and the current sources are replaced by open circuits, as I mentioned. The passive elements RLC all should be represented by short circuit. So let us now explain how to get this graph from this network. Node 1, node 2. In between node 1 and node 2, there is only one voltage, one 5 ohm resistance connected. So in between node 1 and node 2, there is one resistance connected, which is replaced by branch B. Similarly, in between node 1 and node 3, there is a 30 ohm resistor connected. So in between node 1 and node 3, this 30 ohm resistance will be replaced by a branch having a short circuit. Similarly, in between node 2 and 3, there is 10 ohm. In between node 2 and 3, there is a short circuit. In between 2 and 4, there is another resistance in between 2 and 4, so short circuit. In between 1 and 4, another short circuit. In between 3 and 4, there is a 20 ohm, so in between 3 and 4, there is 20 ohm. But This current source is nowhere placed here because current source should be replaced by an open circuit. So this is how you can form a graph from a network. Next terminology is node. What is a node? Node is interconnection point of two or more branches. Interconnection point of two or more branches. It is a terminal of a branch. So see, this is a branch. For this branch, these are the two terminals. So these two terminals, 1 and 2, these two terminals are termed as nodes. Now see here, node 1, node 2, node 3, and node 4. Node 1 is interconnection of this one, and this one. These three branches. Similarly, node 2 is interconnection of another three branches B, C, and D. Node 4 is interconnection of D, E, and F. Node 3 is interconnection of C, A, and F. So node is a point which is interconnection of two or more branches. Next is degree of a node. What is degree of a node? It is the number of branches, incident to it. Whether the branch is leaving or entering, that doesn't matter. How many branches are associated with that node is known as degree of node. So for branch 1, for node 1, node 1 is associated with 1 branch, 2 branch, 3 branch. So node 1 is associated with 3 branches. So degree of node 1 is 3. Similarly, you must be able to answer the degree of node 2. That is also 3. Degree of node 3 is 3. Degree of node 4 is 3. So all these nodes are having a degree of 3. As for each case, for each node, 3 branches are incidenting on it. Next is branch or path. What is branch or path? This is one branch. Okay. So branch is a line or path between any two nodes. Okay. So a set of branches that may be traversed in an order without passing through the same node more than once. What does that mean, passing through same node more than once? Suppose here this branch is passing through node 1 twice, so cannot be considered as a branch. Okay. Or see here, this node could not be considered as a branch. These are called loops, which I will be discussing later. Next is loop. Any closed contour selected in the graph. So what are the loops? As you all know, loop is a closed path. Here, this one is a loop. This one is a loop. This one is a loop. Also, this one is a loop. This one is a loop. So all these are loops. So loop means any closed path. 1, 3, 2, 1 is a loop. 1, 2, 4, 1 is a loop. 2, 3, 4, 2 loop. Now let us come to outer loops. 1, 3, 4, 1. A loop. 1, 3, 4, 1. That means this one is one loop. 1, 3, 4, 1. This one is another loop. 1, 3, 4, 1. So all these are loops. So loop must form a closed path. Next is mesh. Let me discuss mesh with the help of this example. This one is a one mesh. This one, second mesh. This one, third mesh. Okay. So all the reds, all the red enclosed paths are mesh. But this could not be a mesh. So green. Which implies, see, this one and this one. These two are two mesh. But this outer one is not a mesh, which implies a mesh should never contain any loop within it. See, for this green one is a loop which contains two other loops within it. So if one loop contains any other loop within it, then it could not be considered as a mesh. So a mesh should be having one loop within it. It should not contain any other loop. So suppose this is a loop. Okay, this is a mesh as well. But whenever this is broken in two parts, this one is one loop, this one is another loop, and outer part is also a loop. But 1 and 2 are two mesh. Outer part is not a mesh because it contains two another loops within it. So this is the concept of mesh. Next is oriented graph. What is oriented or directed graph? As you can see in this example, in this figure, this graph is having all the branches which are having no direction. So the graph which is having no direction of the branches is known as non-directed or non-oriented graph. Whereas these branches, all these branches are having a direction of the branch. So these are known as directed or oriented graphs. So oriented graphs should have branches with some direction. Next is tree. Concept of tree is very important in graph theory. A tree is a connected subgraph containing all the nodes. Very important point. So a tree is a subgraph, means part of graph. This is a graph and this is a tree. So a tree should contain all the nodes of the graph. Here nodes of the graph are 1, 2, 3, 4. So all nodes 1, 2, 3, 4 are present in the tree as well. So tree is a part of graph, that is a subgraph which contains all the nodes of the graph, but no closed path. So while forming a tree from graph, it is to be observed that the tree should not contain any loop within it. Okay. So how to obtain a tree from a particular graph? See here, this graph has different loops, but While forming a tree, the tree should have all the nodes and few branches of the graph. Whenever I'll connect this B, this will form a loop. So this will no more be a tree. So a tree should have no closed path or loop within it. Okay. So tree is open set of branches which are having no loop associated. So the important point here is the tree should contain all the nodes of the all the nodes of the graph. For a particular graph, different trees can be obtained. Okay, someone can choose these 3 branches of the tree. Someone can choose other branches of the graph to form a tree. So it's up to you which branch you will choose. So for a particular graph, number of trees can be obtained. Now, what should be number of branches of a tree? See, suppose you have 2 branches, 2 nodes. So 2 nodes should be associated with at least 1 branch. If these 2 nodes are associated with another branch, this will form a closed path. So while forming tree, for 2 branches there should be 1 path only, or one for 2 nodes there should be 1 branch only. Similarly, if there are 3 nodes, you can connect these 2. So for 3 nodes there will be only 2 branches. If another branch is connected in between any 2 nodes, this will form a closed path and it will no more be tree. So for a tree having n nodes, for a tree having n nodes should have n minus 1 branches. So here we have 4 nodes. So the tree should contain 3 branches. Once 3 branches are chosen, your tree is formed. Addition of any other branch will make a closed path. Now, let us obtain different trees for this graph. This is a graph with 4 nodes, A, B, C, D. For these 4 nodes, a tree should have 3 branches. So all these 4 nodes are to be placed first. Then you can choose 1, 2, and 3. 1, 2, and 3 are chosen to form a tree. Similarly, you can choose another 3, any other 3 branches to form a tree. So 1, 2, 5 is chosen here. Okay. Similarly, another 3. So different possible combination of branches can be chosen to form a tree. So it is not mandatory that for a particular graph, you all will have a single tree. It is not mandatory. You may have different trees. Based on those trees, you may have different results. But finally, you'll get same. Ultimately, you'll get same result for our network. Now, what is twig? Twig means branches of a tree. From this graph, we have got a particular tree. We have drawn a particular tree with D, E, and F branches chosen. So these 3 branches, D, E, F, are known as twig. So twig are branches of a tree, not branches of the graph. Twig are branches of a tree. What is link or cord? For this graph, suppose we have chosen this tree. So while we have chosen this tree, which branches have been omitted? This B branch is omitted. This C branch is omitted. and this A branch is omitted. So the branches which are omitted from the graph to form a tree are known as link. So for a particular graph, we must choose any of the branches to form a tree. While choosing some of the branches, some branches are left untouched. So those branches which are not considered in that particular tree are known as link or cord. So a branch of the graph which does not belong to that particular tree under consideration. So branch B, C and A are not taken into consideration for this particular tree. So these three branches will be called tree, tree link. Now relation between twig and link. For this graph, how many twigs for this graph? How many branches are there? A, B, C, D, E, F. So there are 6 branches. How many branches of twig are there? 3. D, E, F. So from 6 branches, we have considered 3 branches only to form a tree. So remaining 3 should be link. So twig plus link should be equals to number of branches of the graph. So if n is number of nodes, b is number of branches of the graph, and l is number of links, t is number of twig, then t equals to what? Number of twig will be n minus 1. For 4 nodes, there will be 3 branches to form a tree. Now, total number of branches of the graph equals to twig plus link. Now twig equals to n minus 1, so we'll get l equals to b minus n plus 1. So where l is link, so number of links will be total number of branches minus n, that is total number of nodes plus 1. Okay. Now let us discuss what are the properties of a tree. These properties are very important. A tree should consist of all the nodes of a graph. As we mentioned, this tree has all the 4 nodes of the graph. So a tree should have all the nodes of a graph. If a tree is obtained from a graph having n number of, sorry, this should be n number of nodes. If a tree is obtained from a graph having n nodes, the number of twig will be n minus 1. So here, how many nodes we have for this tree? 4. 1, 2, 3 and 4. So how many branches of this tree should be there? That means how many twigs should be there? 3, 1, 2, 3. So t equals to twig equals to n minus 1, which is written here. Okay. N number of nodes. A tree should not have any closed loop. See, in last case, what we have seen? All these trees. All these are trees. Now for all these trees, you cannot find any loop formed. So a tree should not contain any closed path or loop within it. And for a particular graph, different trees can be obtained. So these are the properties of a tree. So let us now discuss one example. for this particular problem, say these are the branches. These are the nodes. Now, if I ask you to form a tree, all these 5 nodes should be there. So for 5 nodes, number of tree branches, that is twig, will be 4. So let us consider this branch, this branch, this branch. 1, 2, 3, 4. 4 nodes we have considered. 4 branches we have considered for this one. Now, if any of for 5 branches, for 5 nodes, there must be 4 branches of the tree. Now, if any other branch is placed, anyone, this one is placed, it is closed path, so no more be tree. If this branch is placed, it will no more be tree. If this branch is placed, it will no more be tree. So while forming a tree, you first look how many number of nodes are there in the graph, place all the nodes and put the branches that is equals to -1, n minus 1, that is number of nodes minus 1. So this is how we can form tree from a particular graph. Now several other trees can also be formed. Let us choose this one. Okay. This is another tree. This is another tree with 4 branches. So likewise. So here today we discussed about the basic concept of graph theory, and we discussed about basic terminologies which are associated with graph theory. In next class, we will be trying to solve an electric network based on matrix approach. So in this module, we'll be discussing about 3 important matrix based approach of graph theory. One is incidence matrix, triset matrix, cut-set matrix. So in next class, we'll be discussing about incidence matrix. As of now, I am ending up here. Meet you in next class.